Welcome to the second podcast on complex numbers. This one is called More on Complex Numbers, Working with Square Roots of Negative Numbers. When in the past you've seen an expression like this, negative the square root of 25, you've just been told that that's undefined. Now that we've introduced the complex number system, we have a way of working with numbers such as the square root of negative 25. Now the reason that you need to have a system for working with these will become obvious in the next couple of sections in the book, where when we apply certain rules, these kind of numbers occur. Now the way we're going to work with these is this. Anytime that you see the square root of a negative number as part of an arithmetic problem, for example, look there at exercise 1 or at example 1. Here I have the square root of negative 32. Here I have the square root of negative 18. We're doing the arithmetic operation of subtraction. Anytime you're getting ready to do arithmetic with square roots of negative numbers, change them to their I form. The I form of the square root of negative 25 is I square root of 25. Now we know that the square root of 25 is just 5, so this is the same as 5i. So that would be its I form. And once you've changed it to its I form, we already covered how to do arithmetic in the I form in the previous podcast, so you should know how to finish it from there. So let's go ahead and try example 1. The first thing I want to do, since that is an arithmetic problem with square roots of negative numbers, is change this to its I form. So I'll write 2 plus 3, and instead of saying the square root of negative 32, I'm going to say I square root of 32. And again, when I get to the next square root of a negative number, I want to immediately change it to its I form, I square root of 18. Now that's the first step. That's going to be the first thing I'm looking for on your test. Make sure you do that step before you do any arithmetic. Okay, now you need to know how to simplify square roots. The square root of 32, you'll recall, is the square root of 16 times the square root of 2, and the square root of 16 we know to be 4. So the square root of 32 is the same as 4 square roots of 2. So I'll come in here and I'll rewrite this as 2 plus, and then remember the square root of 38 is 4 times the square root of 2. So I'll do my 3 times my 4, which will give me 12i square root of 2. Okay, now just to review that, I had 3i times 4 square root of 2. The 3 times 4 gave me the 12i square root of 2. Let's go ahead and change the second one now. The square root of 18 is the square root of 9 square root of 2, so that's the same as 3 square roots of 2. So again, I'm going to have 4 times 3, which is 12i square root of 2. Now I have 2 plus 12i square root of 2 minus 12i square root of 2. The plus 12i square root of 2 and the minus 12i square root of 2 zero each other out, so the answer here is just 2. Okay? Now let's take a look at the second example problem. In the second example problem, I'm asked to evaluate this fairly complicated algebraic expression, and to evaluate it, I'm supposed to use for my value of x negative 1 plus I. So I'm going to rewrite this thing, and I'm going to put an empty hole everywhere that an x occurs. So instead of writing x squared minus 6, I write empty hole squared minus 6. Instead of 2 minus x, I write 2 minus, and I put a big empty hole there. And now I take the value of x, which is negative 1 plus I, and I put it into those empty holes. Now I'm doing it this way because usually when a student does a problem of this sort, they make their mistake on the first step, the substitution step, and that is most common when there are minus signs and negatives, and this substitution problem has both minus signs and negatives to be substituted. Okay, now I just start doing my arithmetic. I'm already in my I form, so I can start to do the arithmetic. Remember what negative 1 plus I squared means. That means negative 1 plus I times itself. Negative 1 plus I again, and we can do that by the FOIL. The first term would be 1. The last term would be plus I squared, which you know we're going to change to negative 1. The center term is negative 1I plus negative 1I, which is negative 2I. And so that is going to be 1 minus 2I minus 1, because the I squared is negative 1. The 1 minus 1 gives you 0, so that's just going to be negative 2I. So I'm going to write here negative 2I minus 6 over. Here we just have to distribute to get rid of that bracket, so I'll have 2, put in my little 1 here, and just so I can distribute a negative 1. Negative 1 times negative 1 is plus 1. Negative 1 times positive I is minus I. Now on the top I notice a common factor, negative 2. So I factor out the negative 2 to simplify the top, and I get I plus 3. And I've taken out the negative 2 correctly if, when I multiply back, I get what I started with. So if I do negative 2 times I, there's my negative 2I. If I do negative 2 times 3, there's my negative 6. So I've done the top correctly. On the bottom, I simply have 3 minus I. Well, look at this. 3 plus I on the top, 3 minus I on the bottom. This is one of those cases where you want to rationalize the denominator, which we showed in the last podcast, and you do that by multiplying top and bottom by the conjugate of the denominator. So I'll say 3 plus I, 3 plus I. That's the conjugate of the denominator, so when I multiply, I'll get no center term. The first term is 9. The last term is positive times negative, negative I squared. Now let's take a look at the top. On the top, I've got negative 2 times I plus 3 times I plus 3. Again, 3 plus I and I plus 3 are the same thing. Now if I multiply I plus 3 times another I plus 3, I get I squared for my first term, plus 6I for my center term, because that's plus 3I plus 3I, and then plus 9 for my last term. Well, my I squared is negative 1, so what I get is 8 plus 6I in complex number form. So on the top I have negative 2 times 8 plus 6I. And notice my scratch work I do off to the side, and I try to keep my main body of work just completely lined up and organized in a straight line here. Okay, well let's see, that I squared is a negative 1, so that's 9 minus negative 1, which is 9 plus 1, which is 10. On the top I have negative 2 times 8 plus 6I. Well, 8 plus 6I has the common factor 2, so I'm going to take out the 2. So I'm going to say 2 times 4 plus 3I. Well, a 2 cancels a 2 in the 10, so I get negative 8 minus 6I all over 5. Now, that's a good final answer. However, that is not the form of a complex number. So if I want my final answer in the form of a complex number, I write negative 8 fifths minus 6 fifths I, and that is the form A plus BI. So that is the standard form of a complex number, and this problem is complete.